China is well known for its remarkable ability to construct tunnels, bridges, and transportation routes, which is why it comes as no surprise that the country is embarking on yet another ambitious project. This latest endeavor involves building bridges that are breaking records and tunnels stretching for miles through mountains, including one dug next to an active volcano. These engineering marvels are all part of a vast infrastructure project, which also features a record-breaking tunnel boring machine, TBM, with a 49-foot diameter, capable of digging through tough terrain. This massive machine weighs 4,000 tons and was designed specifically for this project. But here's the twist. This enormous infrastructure effort is taking place not in China, but in Georgia. Yes, you heard that correctly. China, known for its grand construction projects, is building megatunnels and bridges abroad, setting records in foreign lands. The question is, why does China need a project in Georgia, and what is it all about? Georgia, nestled between Europe and Asia, is known for its mineral springs, with over 730 mineral springs scattered across the country. These springs are a valuable resource, not only for domestic use, but also for export, primarily to Russia. In 2024, Georgia exported 141.5 thousand tons of mineral water to Russia, making up over 50% of its total export of the product, which brought in nearly $77 million, with a 24.4% increase in water sales to Russia from 2023. This trade is clearly on the rise. Additionally, Georgia is a significant producer of citrus fruits, especially mandarins, with a harvest of over 50,000 tons in 2024. While some of this fruit is consumed domestically, a large portion is exported, mostly to Russia, which accounted for 57% of the citrus fruit exports. In 2024, the revenue from mandarins alone reached $6 million. Trade with Russia has become a key driver of Georgia's economy, with the total trade turnover between the two countries reaching $2.5 billion in 2024, a 5.4% increase from the previous year. Trade with Russia now makes up 8.6% of Georgia's GDP. However, this crucial trade route comes with a problem: the road connecting Georgia and Russia, known by various names, such as the Georgian Military Road, S3, Tyalidi, and Stepantsman-Delarsi. This road is the only land connection between the two countries. It's not only used for trade between Georgia and Russia, but also facilitates trade between Russia, Armenia, Iran, and Turkey. In 2024, 4.8 million tons of goods passed through the S3 highway, and in 2021, 332,000 transit trucks moved an average of 177,000 tons of goods daily. Despite its importance, the S3 highway is notoriously treacherous. The Caucasus Mountains that flank the road are not only a stunning sight, but also a source of danger. The road is often blocked by landslides, falling rocks, or snow, making it a hazardous path for drivers, especially for trucks transporting goods. In 2022, a landslide on the 33rd mile of the S3 closed the border checkpoint between Russia and Georgia. In previous years, landslides have damaged vehicles and caused significant infrastructure damage, including the rupture of a gas pipeline to Armenia in 2014, which resulted in fatalities and $3 million in damages. To solve these problems, Georgia turned to the Chinese to help build a safer route through the mountains. The Kvetkobi Road project is being led by China Railway Tunnel Group, and it involves constructing a series of tunnels to bypass the most dangerous parts of the S3 highway. These tunnels will provide a safer alternative for the transport of goods and people, reducing the risk posed by landslides and extreme weather. The project will include 5 tunnels of varying lengths: 636 feet, 980 feet, 1,270 feet, 5,000 feet, and the centerpiece, a 5.6-mile tunnel with a 49-foot diameter. This will be the longest tunnel in Georgia, and its construction required the use of a massive tunnel boring machine, TBM, which is a critical piece of equipment for such a complex project. With a diameter of 49 feet, the TBM is a record breaker in Georgia, though it's still smaller than some of the giant machines used for projects like Hong Kong International Airport. Despite its size, the machine is incredibly efficient, capable of digging 1,400 feet per month. The TBM not only moves forward quickly, but also lines the tunnel as it goes, allowing for faster completion. The challenges for the Chinese builders didn't end there. The geological conditions in the region presented additional hurdles. The rock formations near the tunnel site include marl, a softer rock, and volcanic ash, which is notoriously difficult to dig through. In fact, the tunnel is being built near an active volcano, which adds a layer of risk to the project. However, the builders were well prepared, equipping the TBM with advanced systems to ensure its success, including an active joint system, bidirectional rotation for the cutting head, and a powerful motor capable of generating 22,600 tons of thrust and 9,900 kilowatts of power. In addition to the tunnels, the project will also feature a series of bridges, some of which are quite impressive in their own right. The bridges, ranging from 485 feet to 1,500 feet in length, are designed to withstand the harsh weather and seismic activity in the region. The most challenging bridge in the project will be an arch bridge, 1,400 feet long and 545 feet high, with an arch length of 935 feet. While not breaking any world records, this bridge will be Georgia's first of its kind and a significant engineering achievement for the country. The total length of the new road will be 14 miles, with 2 asphalt lanes built to withstand extreme conditions. This construction will be more challenging than building a road on flat land, as the terrain is mountainous and the risk of landslides and severe weather is ever present. The project will also involve the renovation of an existing bridge and the construction of a visitor center, which will serve as a hub for agribusiness, ecotourism, and community development in the region. However, local residents have voiced concerns about the environmental impact of the project, particularly in terms of its potential effects on cultural heritage sites and biodiversity. The valley in which the project is being built contains traces of human activity from the Neolithic era, and some worry that the construction could damage valuable archaeological sites. Despite these concerns, the project is expected to be a major boon for Georgia. The improved road will reduce travel time between Kvetkobi and Kobe from 1 hour to just 15 minutes, and it will also make travel to the capital, Tbilisi, much quicker. This will not only benefit locals, but also improve trade and tourism, which are vital to Georgia's economy. But why is China so invested in this project? The answer lies in the Belt and Road Initiative (BRI), China's ambitious geopolitical project aimed at connecting countries through a network of roads, railways, energy, and digital infrastructure. Launched in 2013, the BRI is a centerpiece of China's foreign policy and is already operational in over 60 countries, including Georgia. As a crucial point on the route connecting China to Europe, Georgia is an important partner in China's vision of global infrastructure development. The Kvetkobi Road project is just one part of China's broader strategy to strengthen its influence in the region and secure trade routes for the future. In addition to the road project, China is also involved in another major infrastructure project in Georgia, the Anaklia Port. This port, which will be a key part of the Trans-Caspian international transport route, is expected to handle massive volumes of cargo and significantly boost Georgia's economy. The port's construction is being funded in part by a Chinese-Singaporean consortium and is expected to cost around $2 billion once completed. The port will allow for the passage of large container ships and is projected to handle 100 million tons of cargo annually. China's involvement in these projects, while beneficial for Georgia, has not been without controversy. Past projects by Chinese companies in the country have been marked by delays, poor quality, and labor rights violations. Despite these challenges, the Kvetkobi Road project and Anaklia Port have the potential to transform Georgia's economy, strengthen its position on the global stage, and deepen its ties to China and other countries along the Belt and Road Corridor. The Kvetkobi Road project is more than just an engineering feat. It's a vital step in securing Georgia's future as a key player in the global trade network. With China's backing, Georgia is poised to overcome its infrastructural challenges and emerge as a crucial link in the Belt and Road Initiative, helping to shape the future of international trade and geopolitics. What do you do when a river cuts through a city? You build a bridge. Maybe one, maybe more, depending on ambition and necessity. But in China, where pushing the limits of engineering is the norm, they took a different approach. Instead of building over the river, they decided to go under it. In Jinan, the capital of Shandong province, a revolutionary tunnel project has redefined infrastructure. Jinan is no ordinary city. It's home to 9.4 million people and a thriving $90 billion economy, ranking among China's top 20 urban centers. Known for its steel mills, chemical plants, and high-tech innovation zones, Jinan is a powerhouse of industry and education. Its universities are ranked 35th worldwide for scientific research, attracting talent and investment from across China and beyond. Private businesses have also poured billions of dollars into the city, making it a critical hub for economic development. But Jinan had one issue: the mighty Yellow River, often called China's Mother River. While 15 bridges already spanned its waters, they were no longer enough. The city's rapid expansion and growing population meant increased traffic congestion and longer travel times. Simply adding another bridge wouldn't be enough to solve the problem. Instead, authorities envisioned a more ambitious project, a tunnel beneath the riverbed, something that had never been attempted at this scale before. The plan was groundbreaking in every sense. Unlike typical river tunnels, which are often much smaller in diameter, Jinan's tunnel would require a record-breaking 56-foot wide bore, making it the largest underwater highway tunnel in the world. The scale and complexity of this engineering feat immediately attracted global attention, as few projects of this magnitude had ever been undertaken. Construction began on September 1, 2024, with a tight timeline and immense logistical challenges. Engineers had to navigate unstable riverbed sediments, high groundwater pressure, and seismic risks, all while ensuring the tunnel remained structurally sound for decades to come. The tunnel wouldn't just be big, it would have to be exceptionally strong, waterproof, and capable of withstanding extreme geological forces. The project is a testament to China's growing expertise in megaprojects. With cutting-edge tunneling technology, meticulous planning, and a highly skilled workforce, Jinan's underwater passage is set to redefine how cities tackle transportation challenges. Construction of the nearly 4-mile-long tunnel beneath the Yellow River began on September 1, 2024, and immediately captured global attention. The reason? Engineers planned a tunnel with an unprecedented diameter of 56 feet, making it the largest tunnel of its kind in the world. This extraordinary size set the project apart from other famous underwater tunnels. For comparison, the Channel Tunnel between the UK and France, one of the longest tunnels in the world, is much longer but has rail tunnels that are only 25 feet wide. In contrast, Jinan's tunnel would dwarf such tunnels, offering a completely different scale of engineering innovation. The size of the tunnel posed unique challenges, especially due to the immense water pressure and the unstable geological conditions of the riverbed. To ensure the tunnel's durability and resilience, engineers had to incorporate state-of-the-art technology and design elements. Over 1,600 protective ring segments were installed along the tunnel's length to safeguard it from collapse and ensure the structural integrity of the passage. These rings act as a shield, distributing the immense pressure and mitigating the risks posed by the shifting geology beneath the river. Moreover, to accommodate the high volume of daily travelers, the tunnel features a revolutionary two-tier design with a total of 6 lanes. Vehicles traveling in one direction use the upper level, which is 18 feet high, while traffic in the opposite direction flows through the lower level, which is 15 feet high. This design allows for efficient use of space and ensures that traffic moves smoothly, with vehicles reaching speeds of up to 37 miles per hour. The entire journey through the tunnel will take only a few minutes, transforming transportation across the city and drastically improving connectivity. The catch: a toll fee will be in place for the next 25 years to recover the massive investment. But the benefits outweigh the costs. This tunnel alone will handle 7.4% of all river crossings, significantly easing congestion for Jinan's 9 million residents. Perhaps the most astonishing part of the project is the timeline. The underwater portion of the tunnel was completed in just 110 days, a new world record. The secret? Cutting-edge German technology. Herrennicht, a renowned tunneling company, supplied the project with a specialized tunnel boring machine, TBM, named Shanha, designed to handle high groundwater pressure and unpredictable geology. This machine could dig through rock and sediment at speeds of 52 to 59 feet per day. It featured a 7,510 horsepower cutterhead drive and an automatic pressure control system, ensuring safety and efficiency. At full power, Shanha could excavate 1,400 feet of tunnel in a single month, an extraordinary feat for such a large diameter project. The cost of such machinery? A staggering $80 million per unit. China's obsession with pushing engineering boundaries isn't new. Before Jinan's tunnel, another record-breaking underground project reshaped transportation, this time in Hong Kong. Back in the 1990s, Hong Kong's international airport was relocated to an artificial island. To connect it with the city's northwest, China turned to Herrennicht once again. The result? A tunnel boring machine even larger than Jinan's Mixed Shield S-880, with a 57.7-foot diameter, surpassing Seattle's famous Bertha. Construction began in 2013, but digging only started in 2015. At its peak, Mixed Shield S-880 excavated 101 feet per day, completing twin 3-mile-long tunnels by 2019. However, engineers faced a unique challenge: worker safety. Since the tunnels were over 164 feet below sea level, maintenance crews couldn't simply enter and exit freely. Instead, they lived in pressurized chambers, similar to deep-sea divers, and were transported underground in sealed shuttles. Their shifts lasted 6 hours, after which they had to slowly decompress to avoid sickness. The final segment of the Hong Kong Tunnel opened to traffic on December 27, 2020, dramatically improving airport accessibility. At the heart of the operation was a custom-built tunnel boring machine, TBM, named Shanhe, supplied by the German company Herinicht, a world leader in tunnel construction technology. Unlike traditional drilling methods, TBMs like Shanhe can cut through various ground conditions with unmatched precision. Shanhe was specifically designed for Jinan's unique geological challenges, including high groundwater pressure and shifting sediment layers beneath the Yellow River. This advanced machine could excavate at speeds of 52 to 59 feet per day, making it one of the fastest machines of its size ever used. It featured a 7,510 horsepower cutterhead drive, allowing it to drill through tough materials effortlessly, while an automatic pressure control system ensured safety. At its peak, Shanhe could dig 1,400 feet of tunnel per month, significantly reducing the overall project timeline. China has been relentlessly battling desertification for years, and its efforts are often hailed as groundbreaking. From 2016 to 2020 alone, China managed to transform around 21.7 million acres of desertified land into thriving green areas, averaging 4.3 million acres per year. By 2022, they planted another 9.3 million acres, and in 2023, that number reached over 9.8 million acres. These accomplishments sound impressive, but desertification is a massive challenge, and planting trees alone may not be enough to halt the spread of deserts. While the greening program is ambitious, experts warn that if desertification continues, China might have to plant trees for centuries to come. Despite this, the Chinese have found a creative solution. According to researchers at Beijing Forestry University, up to 85% of plants planted in desertified areas die, largely because of shifting sands. Sand particles are constantly moved by the wind, and without something to hold them in place, they leave plant roots exposed, making it nearly impossible for trees to thrive. Desert areas, like the Taklamakan Desert, where 80% of the land is shifting dunes moving at a rate of around 65 feet per year, present a particularly hostile environment. The lack of wind protection and the scarcity of nutrients in the sand makes it incredibly difficult for plants to survive. Still, China has not given up. Every year on March 12th, Tree Planting Day, millions of people across the country plant trees, and citizens between 11 and 60 years old are required to plant 3 to 5 trees annually. However, planting trees in such conditions requires specialized knowledge. For example, while planting in sandy soil might work in some places, it's crucial to know where, how, and what to plant to ensure the plant's survival. This is where a clever, albeit controversial, method comes into play: straw. Straw, in this case, refers to the dried out parts of wheat, rice, oats, and other crops. After harvesting the grain, the leftover straw is often discarded or used for animal feed. With China's vast rice production, generating over 200 million tons of straw annually, the country has found a way to repurpose this resource to combat desertification. The straw is spread across sand dunes in large grids, creating a checkerboard pattern that helps stabilize the sand and provide nutrients for the plants. This method is labor-intensive and expensive, requiring significant resources to transport and set up the straw grids. Trenches are dug, and the straw is carefully placed, but despite the challenges, the results have been impressive. Over time, the straw decomposes and becomes natural fertilizer for the plants, enriching the barren soil. In just 3 years, the straw cells break down, leaving behind a fertile patch of land where plants, like shrubs and desert-resistant trees, can thrive. The benefits of straw are not only limited to providing nutrients for plants. The straw grids also act as barriers, reducing the movement of sand by up to 99.5%. This drastic reduction in sand flow stabilizes the environment, allowing plant roots to remain anchored. The straw also offers wind protection, which is essential in the harsh desert conditions, where winds can be destructive. This combination of factors significantly improves the survival rate of plants in areas where traditional planting methods would fail. To make this process more efficient, the Chinese developed a mechanized solution. Instead of manually placing small straw piles, they created long straw ropes, which can be quickly laid down over large areas. These ropes, produced in factories, are more efficient, lasting up to 6 years, twice as long as traditional straw, and can be reused. The process is now 60% more efficient than the previous manual methods, saving time and labor while maintaining effectiveness. But even with these innovations, China went a step further. They designed a vehicle that can automatically lay the straw ropes, dig trenches, and plant seeds, all with minimal human intervention. This fully mechanized process allows for a much faster and more efficient system of combating desertification, reducing the need for manual labor and enhancing the overall speed of implementation. Despite these advancements, sometimes the terrain makes it difficult to use the automated machines. In such cases, workers dig trenches by hand and then use machines to cover the straw with sand. Though not as efficient as the fully automated system, this method still allows for a significant reduction in labor and time compared to the traditional manual methods. One might question the real-world effectiveness of these straw grids. The proof is in the results, especially when we look back at the construction of the Btu-Lanzhou Railway in 1958. Stretching 615 miles, 87 of which passed through the Tengger Desert, the railway was initially thought to be impossible to build. Experts predicted that the railway would be buried under sand within 30 years. However, the Chinese engineers successfully stabilized the sand using straw mats and, later, straw cells. The straw cells not only helped stabilize the sand, but they also supported the growth of desert-resistant plants, turning the desert areas around the railway into green spaces. This solution became a model for the rest of the country, and in 1988, it was awarded a special prize for national science and technology progress. Today, the railway remains operational, and the sand protection system continues to protect it from desert encroachment. The success of the straw system did not go unnoticed, and soon other countries, battling desertification, adopted similar methods. The idea of using straw to stabilize sand dunes spread internationally, and many areas suffering from desertification began to see improvements in their own ecosystems. Fast forward to 2022, and the Chinese have once again shown their commitment to fighting desertification. The country opened its first high-speed highway through the Tengger Desert, a project that involved more than just laying down asphalt. To protect the highway from the desert's harsh conditions, a multi-layered system was put in place, including gravel belts and, of course, straw cells. This innovative solution saved millions of gallons of water and building materials and made the highway eco-friendly, demonstrating the versatility of straw in combating desertification. The success of these methods is not limited to just railways and highways. China continues to use straw and other innovative techniques to protect roads and infrastructure passing through deserts. For example, the Taklamakan Desert, known as the Sea of Death, is home to a highway that spans 349 miles. To protect this vital transportation route, China employs straw cells and plantings, ensuring that the desert does not swallow the road. China's efforts to combat desertification have evolved significantly over the years, showcasing the country's remarkable ingenuity and unwavering commitment to preserving its land. What started with basic tree planting has now grown into a sophisticated and multifaceted approach. The introduction of straw grids, which act as barriers to prevent sand movement, has provided a novel solution to protect newly planted saplings in shifting dunes. These straw grids, combined with mechanized machines for laying the straw and digging trenches, have drastically increased the efficiency of the planting process. This system allows China to cover large areas quickly while ensuring the plants have a better chance of survival in harsh desert conditions. Beyond this, China has also developed advanced methods, such as creating straw ropes that are laid down mechanically, reducing labor costs, and improving the durability of the sand barriers. The incorporation of plantings into these grids adds another layer of protection, as desert-resistant shrubs and trees help to stabilize the soil over time. This evolving strategy is not only about mitigating desertification, but also about creating a self-sustaining ecosystem where the desert becomes a thriving environment for plant and animal life. Although the battle against desertification is far from won, China's innovative solutions are proving highly effective in transforming barren deserts into green, thriving landscapes. With continued investment and adaptation of these methods, China is well on its way to reducing the spread of desertification, ensuring a healthier and more sustainable environment for future generations.